Resume recording. All right, so we are recording now. Let me share this again. Share this screen. All right. So now my problem is how to get rid of this program window. Maybe I do it like this. Yeah. All right. Now, crash course in MATLAB. Did you use MATLAB before? Anybody who used? Okay, Cem used, Furkan used, Hakan used. So Zeynep and Ali are new to MATLAB. This is easy. You say A is equal to 1 and A is 1. Is my screen too small in your... maybe I can try to...
Hocam, we can zoom on the computer ourselves.
Okay, that's nice, but it's, it's a little bit hard for me to see too. Editor. Uh, so there should be some settings here. Can I zoom in maybe? No? Spelling outline. What's outline? So every different version, I'm having difficulty to find settings.
Hocam sağda.
Nerede?
Yukarı gelin hocam şeyde.
Şu mu?
Home'un içinde sağ tarafta.
Onun
Sağdan
içinde
4.
sağ taraf. Copilot.
Sol, bir sol. Bir daha sol hocam.
Settings. Bravo.
Aynen. Aynen.
Teşekkürler. Şimdi buradan
View.
View,
Appearance var hocam en üstte ikinci. Aynen.
Appearance, Colors, Fonts. Okay. So maybe 14. Okay. Is it any better? I can make it larger. 18. Okay. I think this is better. Okay. So if you say A is equal to 1, A is 1. If you say, let's say, I wanted to say a different number. So you can say 8 times 8 is 24. B is 8 times 4. So you got B12. 8 times B, So it goes on like this. The good news about MATLAB is it has advanced libraries. For example, when you have A, you can also, by double clicking, you should be able to open it. I couldn't. Is it locked? Okay, open selection. Oh, what happened? I want to get rid of this. There should be a way to close it. If I close it, then I won't be able to open it, probably. Now, okay. So I need to close every file once it... Allah Allah. Peki, şöyle bir şey deneyelim. Anyways, so this is my A variable. I can go to Excel and I can copy all of these things. And here I can paste it. So now I have all the information available to me. CLC clears the screen. So for example, now I can use a command like plot. A plot is used to plot graphs. And since I have this as a variable A, I will say all of the values in the first column. So this is like a matrix. And if you put this, what is this, semicolon? Column. So if you write it like this, it's going to plot everything in the rows and the first column. Then, for example, you can say all of the rows and the columns from second to the fourth. So if you plot it, if you write it like this, hopefully it will plot our graph like this. So it is very similar to what we have seen in Excel. One trick you can do is, for example, for 2 seconds, it's almost like the peak here. So you can count the number of peaks: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 of them in 4 seconds. So what's the period, huh? Or what's the frequency? If you have about 14 peaks or 14 sine waves in 4 seconds, you can divide 14. You can divide 4 seconds, and it's a little bit less than that, I think. So many seconds with 14 waves. So this is seconds. If you divide it with the number, it is the period, isn't it? Seconds. So if you take the inverse of the period, that's in hertz. So I expect this thing to be around 5.6 hertz. So how else do you find it? If you have 14 cycles in so many seconds, so how many cycles per second? You can directly divide this, and this number is the same as this one. So how do I do it with fast Fourier transform? So I come to here, I plot the graph, right? And look at here, you have some other interesting frequencies here. So I will look into all of them. This yellow one seems to be the last one. Usually blue is the first data, red is the second data, and this one must be the third data. So I will go something like B is equal to absolute fast Fourier transform of the A, isn't it? And I will say which column now. It should be the fourth column. Can you follow? Now I'm taking the fourth column and all of the rows of variable A. So this is 6,129 data points long. I'm taking its fast Fourier transform. So this is going to be a complex number. So I will take the absolute value of this, which is a squared plus b squared within square root. So now b variable is basically my fast Fourier transform, its absolute value. So it's done. It's much easier than Excel. And it can take any data points, including 6,129. So now I will plot this. So to plot into a different figure, you say figure number 2, because this is figure number 1, right? I think so. Yeah, here, figure number 1. So in figure number 2, I will plot it as something in the x-axis. I will write this. And in the y-axis, I will plot B. So that's my command. So how do I generate the frequency domain? Do you remember from last class? By the way, how many minutes do we have left? I don't know how to see. I think in the last 10 minutes it will.
It says 2 minutes.
2 minutes. Oh, it didn't warn me for 10 minutes. Okay, so let me try to do this in 2 minutes, and then we give 10 minutes break and we continue. Is that okay with everyone? Okay. So for the x-axis, that's the x-axis of the fast Fourier transform. So I will have delta f values. So delta f values were something like this, isn't it? So our sampling rate is 505.8. So that's going to be 505.8 divided by number of data points, 6,129, 6,129. So that's my delta F. And I will multiply this with an array from 0 to 1 less of this 6,128. So I kind of wrote a small program from 0 to 6,000 something divided by 6,129, so it's normalized, times the frequency. All right. So, that's it. Oh, look at this. Now I can zoom into this here. So this is some real data. I see one peak, so that's the dominant one. And these are some additional ones.